Welcome and hello. This is a video tutorial on HEC ResSim, and in today's lesson, I'm going to discuss reservoir storage balance. This lesson is more of an introduction to the topic and describing the differences between implicit system storage balance and explicit system storage balance. The next video will actually do some clicks and make some modifications to the network. A reservoir system in ResSim is defined as two or more reservoirs that operate together to achieve the same goal. Reservoir systems are created by defining operation rules for two or more reservoirs. In the case of the system having reservoirs in parallel, like shown in this network, a user can define downstream control rules which are described in lesson 29 and 30. However, if you have a network with two reservoirs in series where one is upstream from the other on the same stream alignment, the user can create tandem operation rules, and those are described better in lesson 35. The storage balance across a reservoir system is based on system storage zones, and those zones are defined two separate ways. Implicitly is the default, and then explicitly is considered the user-defined method. Now I'm going to use the network on the screen here to hopefully explain the difference between implicit and explicit. Say we have three reservoirs and they are in parallel as shown here, reservoirs A, B, and C. All three reservoirs have a total storage capacity of 50,000 acre-feet. However, they all have different guide curve storage volumes. Reservoir A has a guide curve of 20,000 acre-feet. Reservoir B has a guide curve volume of 30,000 acre-feet. And Reservoir C has a guide curve volume of 40,000 acre-feet. So if we look at all three reservoirs in the same system, there's a total capacity of 150,000 acre-feet. And there's also a guide curve volume of 90,000 acre-feet. Remember, 20,000, 30,000, and 40,000. Balance in this system is achieved if one of two conditions are met. Either A, the volume in all three reservoirs exactly match the guide curve, or B, the volume in each of the reservoirs is proportionally short of the guide curve or over by the guide curve by the same percentage. What I mean by that is, say for instance, we had 90,000 acre-feet of water, and it's distributed 20,000, 30,000, and 40,000 acre-feet. That would be a system in balance because it matches the guide curve volumes. But if there was a shortage of 9,000 acre-feet across all three reservoirs, the system would still be balanced if that shortage was distributed equally across all three reservoirs based on their guide curve volume. So like I mentioned, if there's 9,000 acre-feet shortage, then that would be a reservoir shortage of 2,000, 3,000, and 4,000 acre-feet. So Reservoir A would have 18,000 acre-feet of volume. Reservoir B would have 27,000 acre-feet of volume. Reservoir C would have 36,000 acre-feet of volume. They would be 90% of their guide curve volume, but that would still be considered a system that is balanced. That's considered implicit balance. That's the default that ResSim uses, but it's a linear relationship between a volume of 0 and a volume up to the guide curve. If the total volume exceeds the guide curve, a balance can still be achieved if the same linear relationship exists when filling the reservoir volumes from the guide curve up to a full capacity. So to give you an example of that, again, let's start with the volumes in the three reservoirs matching their guide curve volume, 20,000, 30,000, and 40,000 acre-feet. If the system had an additional 30,000 acre-feet of water added to it, how should that water be distributed to maintain balance? And the answer would be, if you think of a linear relationship between the volume of each of the reservoirs at their guide curve volume up to a full capacity, we would actually distribute that additional 30,000 acre-feet of water proportionally based on how much additional capacity each reservoir has. The additional capacity in Reservoir A is 30,000 acre-feet. The additional capacity in Reservoir B is 20,000 acre-feet. And the additional capacity in Reservoir C is 10,000 acre-feet. So across all three reservoirs, there is a system capacity of 60,000 acre-feet. 30 out of 60 is 50%. 20 out of 60 is going to be 1/3, and then 10 out of 60 is going to be 1/6. So if we had that 30,000 acre-feet of water that we still had to add across all three reservoirs for the system to be balanced, we would add 15,000 acre-feet to Reservoir A, we would add 10,000 acre-feet to Reservoir B, and 5,000 acre-feet to Reservoir C. Now the volumes in these three reservoirs would be 35,000 acre-feet, 40,000 acre-feet, and 45,000 acre-feet, respectively, for reservoirs A, B, and C. That, again, is what ResSim calls implicit system storage balance method. The explicit system storage balance method says you don't necessarily need to distribute that 30,000 acre-feet of extra water based on the remaining capacity. The user can go into ResSim and add inflection points to modify the behavior about how those reservoirs fill up past their guide curve volumes. And at the same time, when the total volume is below the system guide curve volume, inflection points can be added there as well to define what is considered a balanced reservoir system. The decision makers and the reservoir operators may want to fill up Reservoir A to full capacity. And we started at 20,000 acre-feet. If we had an additional 30,000 acre-feet, we could say Reservoir A should fill up to 50,000 acre-feet before adding any additional water to reservoirs B and C. Or maybe Reservoir B should fill up, and when that's full, Reservoir A should fill up, and then Reservoir C. So the reservoir volumes can be filled up in different ways. It doesn't have to be linear, but if you don't want it to be linear, the user has to explicitly go into ResSim and specify what constitutes a balanced system across multiple reservoirs. Well, that's it for my explanation on uh, implicit and explicit system storage balance methods for reservoir storage balance.